Hello, we're back again with another Web Dev Office Hours. Move my camera up a little bit. There we go. Now I'm nice and centered. I like that. Yeah, we need to do some stuff before we get started. Give me 1 minute. Okay, I think I am ready. Just about. 1 second. Just hold on. Just relax. Okay, cool. Let's get into this. I'll share my screen. Screen 2. And where we picked off from yesterday. Let me get my code editor over here. VS Code, very nice. Let's bump up the size. There you go. And where we got from yesterday was we created some tests. I think we finished the tests for HTTP request. Yeah, we're basically just saying, hey, let's make sure that whatever argument we pass to the node fetch execution, or whatever argument we pass to HTTP request also gets passed to node fetch, basically like that. And we covered that. The way that we can ensure that we're testing that and not actually sending an HTTP request is by using a mock. So Vitest is the library we're using to write our tests. And Vitest ships with this little VI test utilities tool where we can access a mock feature. It's going to mock the node fetch module, and the node fetch module is being imported in our actual business logic code. So that's what we've got. We actually haven't implemented this library entirely, but that's okay. That's as far as our tests are going to get us for that. Now, I have another test here, and this is an interesting one because my code, it's technically a module that we're building, but the module behaves, I think, exactly like URL search params. And why are we not just using URL search params? Because this environment is a Akamai Edge worker, and URL search params is an API that's built into Node and into the browser, but it's not actually part of the JavaScript language. So Akamai Edge Workers provides that, not on the global level, but as a built-in module you have to import. Hope that's clear. So how am I going to test this? It's probably going to look something similar to this test. So I'm just going to copy paste that over. And then we're going to say that this is a URL search params. We don't need this node fetch. We'll keep faker because I like that. We'll keep all of the Vitest utilities. And what do I want this to do? I think I'm going to look into like Vitest, and I want to look at the guide, I guess. Now I'll do a search for mock globals, import actual. Let's see, globals. I can say globally. Mock. What up, code thin? Sorry if this is a noob question, but what exactly is testing? Oh my gosh, what a great question. Yeah, let's jump into that. So let's say I have a file in my folder, right? And it's just going to be like, what do we want to call it? Code thin. Yeah? No, code thin. Code thin dot JS. And we want to create a function that does something like, hmm, I'm going to create a function. It's going to export the default function, function. And what do we want it to do? Let's just say, I mean, this is always the go-to, but let's say it takes a number and it returns number plus one, or number, let's like number times number. We're going to export a default function that basically squares two values, right? Right, because why did it rename that? Number input, whatever. So this is a function that's going to square two things, right? So now what I'm going to do is I'm actually going to copy this to a function or a file with the same name, but say it's, dot test. That way they live right next to each other. And what is a test was the original question. Well, when you write code, you want to make sure that the code you write works in the same way that you expect it to work. So I don't know if that makes sense, but essentially it's a way to guarantee that as your application works, you're not introducing bugs. It's not going to catch every single bug, but it's one of the tools we have available. So what I can do is I'm going to go back to one of my other tests, and let's say I can write a test that looks something like this. So import my module from, and then whatever the file name is that we called it, code bin. Please tell me if I'm saying that wrong as well. So yeah, so that's a function, right? And what we can do is we can describe our suite of tests or all of the different tests that we want to run on this one. So this is a pretty basic function. It really only does one thing. So we only need to write some tests that make assertions about what it does. So we can say, like, I'm going to use this describe keyword to say, I'm going to describe my module. So in this case, I'm going to call it this. This is, you don't have to, you can call it whatever you want. I use this syntax. It'll make more sense in a moment when we actually run the tests. And then we provide it with a function that runs. And what we basically want to do is inside of this description of the test, inside of the description of the test, we actually want to create a test. We're going to say test 10 to keep it more simple. Oh, is it 10? Am I reading that wrong? 10. Okay. Code 10. Where are you from? 10. 10 is a great name, but code 10. It's kind of hard to explain how to pronounce that just over text, I'm sure. Anyway, I hope I'm not butchering it. So we can create a test that says the first thing is a string where we're describing what it is that we're testing. So I'm going to say it squares the input value, right? And then I'm going to, that accepts a callback function. And this is what this is where the test actually runs. So we're going to say like const, my input is going to be, faker, is going to be Faker. Now, Faker is a library that can generate just random data in Southern California, but my parents are Vietnamese. Oh my gosh. I don't know if you've been to Vietnam. I freaking love Vietnam, though. It was amazing. Amazing place, amazing people, amazing food. Loved it. So we can say data type. So Faker is a library. It generates it's a library that we can use to generate a bunch of fake data. So why do I want to generate a bunch of fake data? Because well, let's actually run this like a simple way without Faker to begin with. Simplify things, bring it back a bit. So if I know my input is going to be 2, then I would say, or I can use this expect function to say that I expect if I call my module, or let's say input is 2, right? Let's say const results equals, I execute my function with the input. And then down here in my test, I can say, cool, well, in that case, I expect the results of that function to equal 4. And some of this syntax varies depending on which testing library you're using. We're using Vitest. So it runs pretty quick. It's got a lot of nice features built in. I like it. It's great for JavaScript. If I hit save on that, and then I can go to my console and I can say npm run test, which is my testing command. I'm going to pass another argument to see if I can just define the file that I want to test. So that's kind of what the file looks like. The name of the file, Vitest, yeah, it runs with that. So we should only test that one file, hopefully. So this takes a little bit of time to boot up. And patiently waiting. It's funny because Vitest is supposed to be really fast, but I notice how the startup time takes a while. So that took like 18 seconds. Okay, so what we have here is our tests, right? This is telling me which test ran, and then it's not showing me where any of the failures are. So we're just saying, cool, we tested one file, and in that one file, we have one test that passed. Makes sense, yeah? Cool. This can actually be probably a little bit better because we can say we expect it to be input times input. So now if we change this to 3, it's still going to work. And I think that that actually just reran really quick in 9 milliseconds. So that's where Vitest is actually really fast. So now what we can do is, this is the point of testing, is now that I have some tests that basically cover all of the use cases for my JavaScript module, I can go and start making changes to my project with a little bit more confidence that as long as these tests pass, I know that I haven't broken anything. So I can say, cool, when this thing runs, we're going to console log the number input. So now we've introduced some new functionality to our code. And as long as my test runs, it ran again. There you go. There's my console log outputting the number 3. But my tests are still passing. So even though I've introduced some functional changes, I know that I feel pretty good that I haven't introduced a bug, right? So what happens now is if part of my changes do something like, and again, this is a really trivial example, but if I introduce a change that this function is actually going to square the input and then add 1, and I hit save, now when my tests run, it's going to fail, right? Because my test suite is going to say, oh, wrong file. My test suite is going to say, hey, we know that, or we're generating an input of 3, and we're expecting the output to be 3 times 3, which is 9. Does Vitest have any association with Veet? Yes, actually. Veet is designed to be a project, like a JavaScript project bundler. So you can write a bunch of JavaScript in a bunch of different files, and it can like squish that all together and optimize it and make it, uh, modern or backwards compatible or whatever. Do all this work that you need it to actually generate production quality code. And one of the downside or one of the challenges of using Veet is because it's a relatively new project. It has a relatively young ecosystem. And one of the results of that ecosystem being so new is that the previously like older testing tools like Jest that were very popular, they don't actually work with Veet projects for a number of different reasons. So yeah, that was a problem that was being experienced by the Veet community, and some members of the community decided to do something about it and create their own testing tool that actually looks and behaves a lot like Jest, but is fast and works with Veet, and they can actually share the same configuration file if you're familiar with Veet. So it's pretty cool. Yeah. So now what we have in our code, right? We're basically treating our tests as like the sanity check to make sure that if we make changes to our code and we run our tests, if the tests pass, we feel like pretty good that we haven't broken anything. If the tests fail, then one of two things happened. Either we accidentally introduced a bug into our software and we need to fix it, or the software actually works as intended, but the tests were not set up properly, right? So in this case, there really isn't a right answer. Like if this function was designed to just square two values, then yes, we introduced a bug. If it's supposed to square two values and then add one, this is working correctly, but that means that we have to update our test suite, right? The other thing that I wanted to point out is as you write tests, it depends on which library you're using. In this case, we're using Veet, so a lot of a lot of tests will sort of follow a similar format like this, where you describe just like the suite of tests, which is like a collection of different tests, right? I have one test for that. I can do another test to say um, let's see, returns uh, undefined if the input is a string, right? So now if I say, uh, this is actually going to be hello, I would expect results to be undefined, right? So yeah, now we have one test suite with two tests in it. But as we look at our test results now, we see a couple of errors. One is this whole thing is telling me, hey, this is the test file you're running. This is the block within that test file that has uh, the collection of tests that have failed. And these are the two tests that are failing, right? So let's say we want to fix this squares the input value. Cool. We can go to our code. We can say, oh, I found the bug. There's the bug, right? So I fix that. I go back to my test suite. Vitest reruns tests automatically. So we don't have to restart this. It's just going to run. And we can see that now we have here's where the rerunning the test has started. So we see that our test file with two tests in it has one collection of tests. Uh, the collection of tests has two tests within it. The first test is passing. That's why we get the little green check mark. And the second test is failing, which is why we have the red X. So what failed here? And it goes even further to tell us, hey, in this test file, uh, in this collection of tests, in this test, we're getting an assertion a failure, where it's expecting NaN to be undefined. The reason why it gets that, actually, this might be even cooler if instead of doing it that way, I keep it how it was to I want this to actually say to be, and I can say undefined. So this is saying I expect this value to equal that value. Maybe I should use equal undefined. So when that reruns, now we get something else. You may not have noticed the difference, but by using to be or to equal, we actually get the expected value here and the value that we received. So this makes sense. It makes sense because it actually is a broken test, but it makes sense according to our code, right? If I were to pass a string in here and we tried to do a string times itself, what JavaScript is going to do, the way JavaScript actually behaves, is you can take, var s equals what up, and if I try to do s times s, I'm going to get not a number because, in fact, s is not a number. So what we can do now is we can say, hey, if the type of number input is not a number, then we can just return undefined, right? Maybe we even want to like wrap that in the curly brace, whatever. So here it's complaining because returning undefined, I don't actually technically need that. I can just return, and that's the same thing. And now we're adding a little bit of a type guard to say, hey, this is expecting a number. So if you ever receive anything that's not a number, just exit early. And otherwise, we know by this point we have a number, so we can remove or we can return that number squared. So if we go back to our tests, and we see now that after we've rerun our tests, this file has a single file with two tests in it, and they're both passing. Cool. Does that answer your question about what is tests or why do we write tests? I hope so, but I'm happy to go into more detail. Let me know. Otherwise, yes, that was great. You're great. Thank you. I appreciate that. Cool. So I'm going to get back into where we were. Were you on any of the streams before where we built the project, or are you just stepping in first time today? Any resources for beginners to learn more about this? Ooh, I'm sure that there are. I'd say, I mean, really like just kind of Googling it. I don't know off the top of my head what's a good beginner friendly resource for testing. But maybe start, if you're curious, you can start with Vitest. It seems like a pretty good, robust testing tool. It is new, it is young, which means there may be some changes, but as long as you're okay with dealing with maybe the API changes and something breaks at some point, as far as just learning how to test and how to write tests, it should be fine. So that's probably where I would start. It seems like a really cool library. And then, yeah, just like Googling and just, it's going to be a lot of information at once. There's going to be a lot of words that don't make sense, like mocking and stubbing and spying and all this stuff. And I think just, get a little bit at a time and understand a little bit at a time. The most important thing is just like figure out how to write a test, which we just did. And then eventually you're going to run into some more complicated things. It's going to be hard. Testing can be difficult, but it's an extremely valuable extremely valuable skill to have, because as you work on a project, especially really big projects, when you make changes and the project is not well tested, it is so scary to make changes because you're like, fingers crossed, I hope I didn't break something. Especially projects that someone else has built or whatever. So testing is really cool. it makes you feel better, and it catches some errors. Like in this project that we're writing the test for, it actually helped me catch some errors that I had made. So yeah, let's look really quick at what the project is so you can get a better idea of what's going on. I've got my local server running. And for a couple of weeks, I spent this time building out uh, a little weather forecast app where you don't have to worry too much about the details, like the technical details. It runs on Akamai edge workers, whatever. So it can grab the user location. Right now, this is just randomly generated fake data. I could do a search for like Portland, or you said you're in Southern California, right? So what's a good city in Southern California? Like a weird one. I don't want to do like LA or San Diego. Um, what's a good city in Southern California? Vista? I think Vista. Or La Jolla. Let's check out La Jolla. La Jolla, California, right? So it's a weather app. It takes this search string that you search for, gives you the weather, whatever. It's built to be very accessible and very fast. But it has some functionality that it needs to do. It needs to make API requests to Open Weather Maps API, and it needs to do some stuff with cookies and all this, whatever. So as part of the project, I have these modules that I've built that do like quite a bit of logic and have some requirements for how they work. So for me to know that those are built and working properly, I have to write these tests. So like this huge test file that checks all of these different scenarios and cases. And that way I know that if I make a change to my logic, I will know if I broke something, because pretty much every single line of this test has been verified that it works. Every part of logic, not every single line necessarily. So where was I? Yes. I've gone through these 4 modules, or 3 of the 4 modules that I need to write tests for. I'm on the last one. And this is a very simple module, because actually what it does is just export a built-in Node API or like class. So it should be pretty easy. There's not a lot of functionality. I basically just need to make sure that the class, when I call the module, it's actually being executed. Hope that makes sense. But if I call like URL search parameters here, let's say const my input equals whatever, a string, right? And I say const at what scale should you start looking into testing? At a glance, looks like the tests are more complicated than the code to me. Yeah, that's a good point. It's hard to answer that question, because like every developer ever says ever, it depends. But it depends on the importance of the quality of that project. If it's just like a dummy project that who cares if it goes down, or who cares if you introduce a bug and it accidentally says like insults the users or whatever, you don't ever really need to test it, right? It's because it's not so important. If a project is really, really important and you absolutely need to make sure that you're not leaking user private information or something like that, it can be a relatively simple project, but you want to make sure that it works as expected. Or maybe it's a project that could like cost you a lot of money if something goes wrong, right? So it's not necessarily the scale of the application. It's how much, it's how comfortable you want to feel that the code you're writing is not going to break something. And that's one of the variables, like size of application is just one of the variables that goes into that. It could also be if you're working on a big team, you want more people to make a lot of changes, and you want to make sure that the team feels good as a whole, that when these changes have occurred, nothing breaks. Another good point for writing tests, especially working with teams, is you can create your applications in a way that when you introduce new, or if you're familiar with like Git and pull requests and things like that, someone else on the team can create new code and commit it to my Git repo. And then maybe I'm responsible for reviewing that code, the changes look good. Well, part of that review process can incorporate your tests, and it can automate that process. So I, as a reviewer, can look at the changes that you've introduced. And if we're sharing our code on GitHub and I have my project configured in such a way, GitHub can tell me, hey, just so you know, I ran the tests from these changes and it looks like something is broken. And I, as the reviewer, can say, oh, cool, I don't even need to look at this right now. Hey, why don't you go and fix these broken tests and then send some more code with the fixes, and then I can go ahead and review it. And that might like catch some things for you or not. So I hope that answers your question. The short version is write tests when you really need an extra level of confidence that what you're changing isn't going to break something. Best answer I can give you. Okay, so what am I doing? Right, so const URL search params. Let's say query equals new URL search params with my input. Get rid of that because we're not using that. This we may need eventually. So what I'm going to get into next is one of those fancy words that I was talking to you about earlier, and that is mocking. So if you're familiar with making HTTP requests using like a fetch API with JavaScript, generally speaking, when you run your tests, you want to avoid calling fetch requests. You want to avoid making HTTP requests in your tests for a number of reasons. If my test runs and it has like a fetch API call that it's trying to make, that could fail and make my test break without it actually being a problem, right? Like let's say in my case, I'm making API requests to a weather API. If on their end, the weather API is down, well, that fetch request is going to fail. And my test might say, hey, the code that you're trying to check, it's broken because the test failed. When in reality, it's not my code that's broken. It's this third-party dependency, right? So what we can do to avoid that situation is like what I've done here, is I'm creating a mock for a library called NodeFetch. And NodeFetch basically lets me make fetch requests within Node. But because I'm mocking it, I'm saying, hey, JavaScript code, when you come across an import for this library, instead of importing the library code, I want you to just treat that library code like whatever I return here. So here I'm just returning an object with a default property of this is what's called a mocked function. And what this essentially does is it's basically like a fake function. So it kind of behaves like this. It's a function that does actually nothing at all, right? Or a function that doesn't do anything. There's nothing in the content or in the body of that function. So what happens here is if I were to say import node fetch from node fetch, and I try to call it like, say, node fetch http:// example.com. Without this mock in place, it's actually going to import the node fetch library, and it's going to make this fetch request using node fetch. By putting this mock in place, it's going to treat this import like this whatever's returned here. So because we're returning an object with a default a default export, it's actually going to treat it like exporting this, which means this node fetch variable that we've defined is now going to be the equivalent of this function that does nothing. So when this function does get executed, yeah, it's going to take this parameter because it doesn't care whether it receives a parameter or not, and then it's not going to do anything at all. So that's where mocking can be helpful in cases where, particularly making network requests, you can prevent them from actually executing the way that they're intended, but you can give a behavior that behaves like a network request. In my case, we're not using this fake function. We're using what's called a mocked function. So this vi.fn, it's sort of like a fake function, except I can actually grab values from that. So I can say, hey, when this runs, it's a little bit too much to explain today. It's one of those things that I think let it kind of wash over you and understand what you can, and don't worry if you don't understand everything. But this lets me say, hey, when I call node fetch, I want to actually verify what parameters it was called with or what it returned or whatever. It's just helpful for writing tests. That's as far into it as I want to go. So explanations are clear and great so far. Glad to be of service. So I'll try my best. And yeah, if you come into other questions, like just let me know. I mean, part of this stream is me building things that I want to build, but more importantly to me is that people are showing up, having a good time, learning some stuff, asking questions. I don't really care if we work on what I'm trying to work on. We can work on a completely different project if you want. It's all good. But until someone comes up with something for me to work on or another question, I'm going to try and keep going. So here, what am I doing? Oh, yeah, no, I wanted that mock in place. So I want to mock. I don't know how to do global mocks for, because this is not node fetch that we're mocking. Now I kind of want to mock URL search params, which is in Node, it's a global thing. In Akamai Edge Workers, which is the environment where this will run, it's not really a thing. So let me see globals. Globals. Define config globals is true. I don't think that's what I want. So I need to look at, so I know that Vitest is based or influenced heavily by Jest. So maybe they kind of, the documentation isn't quite there yet. Mock global URL search params. So here, URL search params is kind of like a global API in certain and Jest. Oh, is mock exclusive Vitest, or does Cypress have something similar too? That's an interesting question. Yes, so mocking it's not exclusive to Vitest. Mocking, again, some keywords that are very closely related to testing, and they kind of mean similar things, are mocks, spies, stubs. And those are the three that I remember right now. As I understand it, and I think some people have different explanations, we'll start with the easy one, a spy. So what a spy does is it says, I want to essentially take a function that exists and I want to spy on it. Let's just get back into let's actually write a spy. So I'm going to create a function, function say hi is going to take a name, and it's going to return a string that says hi name, right? So it actually has some functionality here. Let's log or comment all that out, and I'm going to say const input equals faker. So it's going to give me a random name. So I want to say faker dot, what do I have? Person? Is person a thing? Address, helpers, faker name. Okay, so cool. It's going to give me a random first name, right? And the reason why we're using faker here, this is important, is I want some sense of random values so that I, as a test writer, I can't like hard code it in because, well, let's say this. Actually, let's go back even further. That's my input. I'm going to say output is say hi of input, and we're going to say hi code bin, yeah? And then I'm going to write my test. I say I expect output to equal hi of the input, right? So there's my test. Let's get rid of that. We're not using that. So cool, everything should work as expected. And then I'm going to run my tests on a file called URL search params. I think because I don't want to run all my tests. I just want to run this one. Search params. So hopefully it'll find that okay. This again is going to take like 20 seconds. Okay, no. Cool. So it found the test that I'm looking for, and it's working as expected. Great. Now, this I can actually make my test break, right? If I write this as a hard-coded string, I could actually go back to my code and I could introduce a bug. I could say return that and hard code this value, right? So now I have a hard coded string. Technically, my test still passes. And this is a very simple example of how of things that could actually happen in real life. If you, maybe it's not hard coded values, but you're making assumptions about what's going on. And your tests are saying, hey, you're all good. This is working code. We don't have to worry about it. Move on with your life. But in reality, having these hard coded things makes it a little bit easier to a little bit easier to break stuff. In reality, having randomly generated stuff or a little bit of chaos makes it easier to get a better test for more random things. So you like user inputs or whatever, it could be a bunch of data that you have no idea what it's going to be, right? So now I'm saying, hey, I want this to be a random name, right? Cool. So now we're saying, oh, what our tests are failing because now we're saying hi to Devin, but in reality, we're always saying hi to Codethin. So that's wrong. Let's go back to like getting our tests fixed. So now we can see it's always going to pass because it's working as intended. But then we can get into scenarios where we don't even know what this is supposed to return, right? Like instead of returning something, what if this was a console log, right? Or no, what if we have say hi, and then what if we have another function that's like function log hi, right? And that's going to take, or just like log results. That's going to take some value and just console log the results. Whatever, rudimentary. The point being that this function doesn't actually return anything, right? So now if we get the output and then we say const logged equals log result of the output, how do we check what this is? There's no return value here, right? So like I can't just be like, hey, I expect the logged output to also equal the same thing. Because the logged output or whatever comes back from that function, it doesn't return anything. It's just always going to be undefined here, right? So what we can do here is instead of checking what the output is, what we really want to check is what this input is. And this is confusing because I've named it output, but this is the output of say hi, but output is the input for log results, right? So we can actually even, we can say, what do I want to do? Let's do this. Input is going to be fake name, right? I'm just going to replace all those. And then we're going to say the log input is going to be the result of say hi to this fake name. So as a test runner, I still have no idea what this value is actually going to be because I'm randomly generating it every time this test runs. So how do I test what this is? Well, what you can do is create these mocks or spies, right? So I'm going to say, instead of calling log result, I'm going to say, or instead of doing this, right, where I actually like execute the code that I want, I'm going to say const log spy, call it whatever you want. And I want this to actually spy on this function called log results. Okay, so here's where things get interesting because what log spy is going to be is it's going to take this function and it's going to return a new function with the exact same functionality of it. We can say console log, let's log what that is. And then let's execute it with the log input. And then I'm going to log it one more time. So we can get rid of that stuff. Well, we can keep that first one. Okay. So all this will make more sense in a moment here. No, it won't. Log spy is not a function. Cool. So I need to look at this API and see spy on. Okay. So just a different syntax. Okay, let's run that again. And we still have something wrong. What do we got? Cannot use in operator to search for getter. Interesting. Spy on that. Okay, I think I don't. Creates a spy on a method or getter setter of an object. Okay. Cool. I'm close, but let's say const some object equals that. It has a method called log results. Okay. And then I'm going to spy on log or some object and get the property or get the method called log results. And then we are going to we're going to do log that object, execute the method, and then log that method one more time. Okay, this should actually give me something more. Oh, come on. Well, this is some object log spy is not a function. Oh, duh. That's log spy. That's not right. That's because that is the return from the spy on. Okay, so this should work. Some object, we're going to create a new spy on that method. We're going to call it log spy. Then we're not going to execute that. Sorry. We're going to get that method and execute it directly. So log results. And we're getting close. Okay, now I've got it. Okay, so what we have here as a result is, we're going to get something back. So let me actually, no, this is fine. So what this allows us to do is we actually get back a function called log results, which I think I can then also execute directly. This is really not a good example, if I'm honest. But we're gonna finish this example. So what is the problem that I'm facing with today? Is that I have this method that I'm trying to execute, right? Some object.log results. But this method doesn't actually return any value. So for me to be able to test and make an assertion to say, hey, when I call this method with this value, with this input, how do I make sure that it's working as intended? Well, the way we do that is we create a spy or a mock. A mock or a spy would kind of work the same way. And I'm going to show you what it does. Is it gives us an object with all of these properties on it. And the one that is most important, in my opinion, is this calls property. I guess call count is pretty good. Results is probably pretty good, but calls. And you'll notice that the first time we log something, the first time we log that that spy here, let me bump that up a bit. The first time we're logging this, we're getting a result, which is an object, and it has this calls property on it, as well as all these other ones that you can ignore for now. And then in the next moment, we actually execute the function called log results, which is why here in our terminal, we actually log the results. And then we get a different function here. Now, okay, yeah, there was something that happened in the middle of my code executing. So once again, here we have before we execute, we have this object that has not been called, has a call count of 0, doesn't have any results, and doesn't have anything in the calls array. And then we execute the function. And this is being logged out from the function. It's not the returned value of the function. And then when we check out our spy one more time after we've executed it, it's been modified. So now we can see that it has been called. It's been called one time. These are the results, which I actually don't understand why there are any results because we're not returning anything. But importantly, we can see that the number of time, or we can see that the calls breaks down to an array with a nested array. So the outer array represents how many times it was called, or each time that it was called, you'll have a new entry in that array. And the inner array represents what parameters that execution was called with. So to make that a little bit more clear, we can say, instead of looking at both of these, this is where we're going to get practical. I can say expect log spy to have been called with log input. Sure. Or I can say I expect it to have been called. I don't like that syntax. I'm going to say to be called, right? Because when we execute it with this input, I expect the spy to be called. I'm literally calling it right here. So that makes sense. And then I expect it to be called with, meaning the parameters that I expect it to use are going to be equal to log input, right? So even though it's not returning anything, I can say, hey, I expect this to be called. I mean, I know I'm literally calling it here, but let's actually even make this more interesting, right? Like, what if we don't call this directly? What if we say, hey, our say hi function is going to do two things. It's going to say hi, and it's also going to say some object dot log results. That's the name. Logging name, right? Now, if I say, if I set up here, say this is going to be the say hi output. Okay, so what our test looks like now is we first generate a fake name, and then we create a spy that we can spy on some object's method, right? And even though we don't directly in our tests, even though we don't directly execute this method, we know that by calling say hi, that method should be executed. And even though we can't get the results of that, we can still test that it's being executed with whatever the input is, right? So I can say, hey, say hi is going to be output this. And I expect say hi to output hi with whatever this fake name is. And additionally, on top of that, I expect my log to be called, or I expect this method to be called. And additionally to that, I expect it to be called with what is it? I expect it to be called with this string. Something's messed up there. There you go. I expect it to be called with this string, right? Boop, something like that. So I hope that was clear. I know that it can be a very complicated thing, but there you go. We can see that our tests are passing, which means that it's actually doing all of this. If I say, "Hey, I expect it to have a exclamation mark at the end," it's going to tell me, "Well, sorry, I know that you're expecting us to say hi to Taryn with an X and be very excited about it, but we're not so excited to see Taryn. We actually just are going to say hi to Taryn, right?" Okay, we can fix that by adjusting our assertion. And then let's get rid of this. And then I can say, hey, well, I expect the log also to be called, and say, we're going to log the name. And that's my assertion. And here, even though our first test passed, we actually see that we're getting something different here. I expect 1, but I received 3 for some reason. Okay. This is a really weird output, but it's saying that because... Oh, because actually, no. Okay, I don't know why, but just a weird syntax for showing us that our test is not working. So that's all the time I have for today. Yeah, okay, you got to go. I got to go too. I'm glad that you were here. I'll be back on Monday at 3 p.m. Pacific Standard, and I'll actually get to finish up the tests that I was trying to write today. But yeah, thanks for stopping by, and hit me up on Twitter if you have any other questions or want some more help. Cool. I'll catch you later.